In this video, I'm going through quadratic inequalities. So before we go through quadratic inequalities, let's just have a think about quadratic equations. So for example, x squared minus x minus 6 equal 0. This quadratic equation, or any quadratic equation, asks a question. And the question is, what are the values of x where y equals 0? Meaning, where does the curve cut the x-axis? Why the x-axis? Well, and why y equals 0? Well, the graph is the graph of y equals x squared minus x minus 6. And we have swapped y for 0. So when we say that the equation equals to 0, we are trying to find the values of x where y equals 0. And of course, y equals 0 is that line there. So that is the line where y equals 0. It is also the x-axis. Remember, the horizontal lines are y equals lines. So for example, this line here is the line y equals 15. Every point, every coordinate on this line has a y coordinate of 15 regardless of the x value. So you can see that for this equation, the graph cuts the x-axis at x equals 3 and x equals -2. But if we write these as a coordinates, it's x is 3, and at this point here, y is 0, and -2, 0. So we found the values of x where y equals 0. So that is a quadratic equation. Now, quadratic inequalities ask a different question. This particular inequality, using the same graph, is asking for values of x where it is smaller than 0. So where values of x that give y values smaller than 0. So it's smaller than 0. So what values of x give negative values of y? Y is smaller than 0. Well, you can have a look. It starts with -2 and 3. And all of these points, coordinates on this section of the graph, the section that is below the x-axis, they will give coordinates where y values are smaller than 0, where they are negative. Let's have a look. If I choose this coordinate there, this is the coordinate -1, and you can see that the value for y is negative. Or if I go for 2, at x equals 2, the value for y on this section of the graph, again, very close to -5. So all of these coordinates on this section of the graph will give values of y that are negative. So the answer would be written in the following way. All the values of x that are bigger than -2, so you see -2 is getting bigger in this direction, but all the values of x that are smaller than 3, these will give negative values for y. So that would be your answer. Now, the next question, same graph, but it's asking, you can see that x squared minus x minus 6 is bigger than, so bigger than 0. So it's asking what values for x give positive values of y, where y is bigger than 0, meaning which part of the graph is above the x-axis. That's where y is bigger than 0, where it's above the x-axis. We're starting with the same two starting points. I start here and there, -2 and 3. And there are two separate sections. So this section, any coordinate that I choose here, is going to give me a value for x and a positive value for y. And any section I choose on this part of the graph, if I pick this point there, it will give me a value for x and a positive value for y. So there are two separate sections on the graph, and therefore I'm going to write this in two separate inequalities. Firstly, you can see that any value bigger than x equals 3 is going to give us positive values for y. So x has to be bigger than 3 for us to get positive values for y. But I'm moving in this direction. Okay, so I'm moving in this direction, so x is smaller than -2. So you get two possibilities. Any value that's bigger than 3 is going to give you positive values for y. Any value that's smaller than -2 will also give you positive values for y. Now you will not be given a graph. You will be expected to solve the equation, and you now have all three ways of solving an equation: factorizing, double or single brackets, completing the square, using the quadratic formula. If it factorizes, I think it's the quickest way to do this. So your step 1 for a question like that is to solve. I will put by factorizing if possible, if it factorizes. So I'm going to put my double bracket, bigger than 0, x times x, 4 and 1, plus 4 minus 1. And then you find your critical values, which are the values for x, and draw the graph. Or let's say sketch, because it's not going to be accurate. So the critical values here, x equals -4 and x equals 1, because we're still solving for 0. So either x plus 4 equals 0, therefore x is -4, or x minus 1 equals 0, so x is 1. And my graph will therefore look like this: -4 and 1. You don't need the turning point. We are not trying to sketch the graph for any purpose except to see which area is under the graph, which area is above. We're looking for bigger than. This is bigger than 0. So that means above the x-axis. That's what we're looking for. So we start at 1 and it's going in this direction, it's getting bigger. And we start at -4 and it's going in that direction, so it's getting smaller. And you write your inequalities, which are your answers. So the final answer is x is bigger than 1, which is that section, and x is smaller than -4, which is that section. These are your answers. And when you come to do your own working, your own classwork, make sure that you have that and the graph and the final answer. So you need to have all four. The next question is x squared minus 36 is smaller than or equal to 0. Now, this is the difference between two squares. You should spot that straight away. That's x plus 6 and x minus 6. So my critical values are x equals negative 6 and x equals 6. I'm going to draw the graph. And I've got minus 6 and 6. And this one says smaller than. So it's below the x-axis. That's what I'm looking for. So it's that section. And because it's just a one section, not two separate sections, your inequality is going to be one inequality. X is going to be bigger than minus 6 because I'm going in that direction. So bigger than minus 6, and it is smaller than 6. And that's your answer. That's the section on the graph where you get negative values for y. Now, because the inequality has a equal there, then you add that to your answer. So if there's an equal in the inequality as part of the question, then there is an equal in the inequality as part of the answer. Again, 2x squared minus 5x minus 3 bigger than or equal to 0. Let's try and factorize first. 2x and x. And I would say 3 and 1. I want to make a negative 5, so it's going to be negative 3, because that will give me negative 6x, plus 1 to give me negative 5. So my critical values, x equals negative 1/2 and x equals 3. I'm going to draw my graph or sketch my graph. Got minus 1/2 and 3, so minus 1/2 and 3. And this says that it is bigger than or equal. So it's above the x-axis. Two separate pieces, this, two separate parts of the graph, and that. X is bigger than 3, x is smaller than negative 1/2, and of course there's the equal, so we're going to add that in. So x is bigger than or equal to 3, and x is smaller than or equal to negative 1/2. These are the answers. Now, this is not going to be a double bracket factorization because there isn't a c, there isn't a constant number at the end, and it's not the difference between two squares. You are allowed to factorize in a single bracket. The common factor is 2x, so we put that outside. And then I'm left with an x minus 3, and that is smaller than or equal to 0. So these are the two parts. Either 2x equals 0, therefore x equals 0, or x minus 3 equals 0, so x equals 3. So these are your critical values, and we move them there. And I am going to sketch the graph. And I've got, let's do a better job. There we go. So 0 and 3. and it is smaller than, so it's below the x-axis. So it's that. And of course there's the equal there as well. So x is going to be bigger than or equal to 0, moving this direction, or smaller than or equal to 3. And that's your answer. Now, just like a quadratic equation, you cannot solve unless it equals to 0. It's the same with the inequality. So your first step is to take away 2 from both sides. So this gives us x squared minus 7x plus 10 is bigger than or equal to 0. We factorize x times x, 5 times 2, both negatives to multiply to make a positive 10. So the critical values are x is 5 and x is 2. And we are going to sketch the graph. And it's going to be there, 2 and 5, and it's bigger than. So these are the values that give positive values for y. That's the section that gives positive value for y. So that's bigger than 5 in this direction, smaller than 2, and also there's an equal, so we're going to add that. So x is bigger than or equal to 5, x is smaller than or equal to 2. Now, if you've got a negative x squared, you need to move everything to the other side. You need to make it a positive x squared. So either you're thinking that you're moving everything this way, and therefore naturally the sign will change, or you multiply everything by minus 1. And you flip the sign. So x squared minus 3x minus 10, instead of bigger than, it becomes smaller than 0. Because if you move it to the other side and it stays like this, it will be x squared minus 3x minus 10, and that will be 0. So still, it's still smaller than. So this one has become smaller than. And we do the same. We factorize x times x, 5 and 2 minus 5 plus 2. So we get x equals 5 and x equals negative 2 for our critical values. And we're going to plot the graph, and it's going to be minus 2 and 5, and it is smaller than. So it's below the graph, below the x-axis, so x is bigger than minus 2 and smaller than 5, and we don't need an equal in the inequality because the question doesn't have an equal in the inequality. Most important thing, keep x squared positive at all times and then solve from there. You can of course have worded questions. The area of the square is less than, so that's an inequality, not an equation. The area of the square is less than the area of the rectangle. Work out an inequality for x. So the area of the square is x plus 1 times x plus 1. So you can write it as x plus 1 squared, or you can write it as x plus 1 times x plus 1, is less than the area of the rectangle, which is x minus 1 times 2x minus 1. Then you will multiply out the bracket. I've got x squared plus x plus 1 is smaller than 2x squared minus 2x minus x plus 1. I always want to keep the x squared positive, so I'm going to take the smaller x squared away, and let's keep it like this. So x squared, and then we're going to simplify, minus 3x plus 1, and this goes 2x plus 1. I'm going to take away the 2x from the negative 3x and the minus 1. I'm going to take that away from there too. So I now have x squared minus 5x. That disappears as well. If you want, you can turn it around. X squared minus 5x, it's still bigger than 0. I haven't actually changed anything. I've just written it on this side because sometimes people prefer to see it that way. So that's bigger than 0. And I've written the inequality. I now need to solve it. This is a single bracket factorization. X minus 5 is bigger than 0. I would still draw a graph to find the section I need. The critical values are either x is 0 or x minus 5 equals 0, so x equals 5. So my graph goes from 0 to 5. I want the section that is bigger than 0. So positive y values, it's above the graph. So I'm either moving away from 0, getting smaller, or bigger than 5. So my actual answer is x is, the values that I want is either x is smaller than 0 or x is bigger than 5. Now let's go back. If you're looking at area and measurements and dimensions, you cannot actually have a dimension that is negative. So x is smaller than 0 is not going to be accepted. The answer, so that's not accepted. The answer that's going to be accepted is values for 5. So when x is bigger than 5, the area of the square will always be less than the area of the rectangle. For this example, we have to choose an answer because it's about measurements, dimensions, and you can't have a value for x that's smaller than 0. And the final example says find the set of values of x that satisfy both equations. One of them is a linear equation, one of them is quadratic. So let's solve the first one first, which is the linear, and then we're going to solve the quadratic. So I will start by reversing the smaller x, which is the negative 6x. So I'm going to add 6x to both sides. So I have 8x minus 6 is bigger than 6. I'm then going to add 6 to both sides. So that's going to give me 8x is bigger than 12. And then I'm going to divide by 8. So that gives me x is 12 over 8, and simplify. So x is, if I divide both by 4, 3 over 2, 1.5. So that's the linear one. And I solve it like I solve a linear equation. The quadratic, first thing I do is subtract 42 because I want to make it equal to 0. So I have x squared minus 6x, and that is minus 40 is smaller than 0. I can factorize that. X times x, 4 and 10. To make 40, I want a negative 10 and then plus 4 to make the minus 6x. So my critical values are x equals negative 4 and x equals 10. I can sketch the graph. Minus 4 and 10. And this is smaller than 0, so I want the section that's below the x-axis. So the answer is x is bigger than minus 4 and x is smaller than 10. I have two answers, but the question says find the set of values. What are the set of values for x that satisfy both equations? So the best thing to do is to draw a number line, sketch a number line. So I've got 0 here, minus 4 around there, 10 is here, and this is 1.5. So 1.5 around there. The first inequality says that x is bigger than 1.5. So I start there, open circle with an arrow, not a closed circle, because a closed circle will suggest that there is an equal in the inequality. And then the other section is I go from minus 4. So let's go here from minus 4 all the way to 10. And which part is overlaps? That's what you're trying to find. You're trying to find the overlap. Well, the overlap is from here to there. That's the overlap. This section is where they overlap. So that section is x is bigger than 1.5, smaller than 10. That is the section for the overlap. That's the section that overlaps, and that is these are the values of x that work, that satisfy both equations. And that's quadratic inequalities.